which graph can check the normality of the data. Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito for you has them all. It's like having a research dream team on demand.
Okay, so if you've ever worked with data, you know this feeling. You're just staring at this wall of numbers. Sure, it's all accurate, but what does it actually mean? Well, today we're going to look at two super powerful tools that can turn that raw data into a clear, visual story you can understand in seconds. Take a look at this. This is a real set of data, just hourly temperatures recorded over a day. I mean, every number's correct, but as a list, it doesn't tell us much, does it? We've got the data, for sure, but we don't have any insight. So, what's the fix? What if I told you that you only had 5 seconds to pull out the key features here? That's the challenge, right? And that challenge sets us up perfectly for our first tool. And that tool is the boxplot. Honestly, think of it like an X-ray for your data. It lets you see the hidden skeleton of the whole distribution, almost instantly. The boxplot is designed for one thing, and that's speed. It gives you this super fast graphical summary of your data's location, its spread, and its skewness. Oh, and it's also non-parametric, which is just a fancy way of saying it doesn't assume your data follows any specific pattern, like a bell curve. It just shows you what you've got, plain and simple. So what's under the hood? Well, at its heart, the boxplot is built on what we call the 5-number summary. This is the absolute bare bones description of your data. It tells you the lowest value, the highest value, and then 3 points in between that slice your data into 4 equal parts: the first quartile, the median, and the third quartile. Okay, so here's how you actually build one. First, you find the median, that's the value smack dab in the middle. Then you find the quartiles, Q1 and Q3, which are just the medians of the lower and upper halves of your data. The box itself is drawn between those two quartiles, and that box contains the middle 50% of all your data points. The whiskers then stretch out to show you the rest of the range, and any points that are way out there get flagged as outliers. Simple as that. And here's the really cool part. You can tell so much just from its shape. If the data's all nice and symmetric, that median line will be right in the middle of the box, and the whiskers will look pretty balanced. But if it's skewed, like this right-skewed example here, you'll see the median gets pulled to one side, and one whisker gets a lot longer. You can literally see the asymmetry instantly. All right, so the boxplot gives us a fantastic general summary. But sometimes we need to ask a more specific and, frankly, a very important statistical question. We can see the center and the spread, that's great, but does our data follow that classic bell curve shape, what's known as a normal distribution? And look, this isn't just some dusty academic question. A ton of common statistical tests, like the t-test, are actually built on the assumption that your data is roughly normal. If you get that wrong, it can completely invalidate your results. So yeah, we should care. You've seen it before, right? The normal distribution, that perfect, symmetric, bell-shaped curve where the average, the middle point, and the most common value are all the same. So many things in the real world follow this pattern, which is why it's become this fundamental benchmark in statistics. The big question is, how do we visually check if our data fits this ideal model? And that brings us perfectly to our second tool, a really clever visual test called the quantile plot, or as everyone calls it, the QQ plot. The idea behind a QQ plot is actually pretty brilliant. Think of it like a police lineup. On one side, you have the quantiles from your actual data. That's basically just your data points, all sorted from smallest to largest. And on the other side, you have the theoretical quantiles from a perfect normal distribution, where those points should be. Then you just plot them against each other to see how well they match up. And here's a great, really intuitive way to read the results. It's called the fat pencil test. If you can imagine laying a fat pencil down over the line of dots on your plot, and that pencil covers all of them up, your data is probably close enough to normal. It's a fantastic practical gut check before you dive into any complicated math. So in a perfect world, if your data really is normally distributed, what do you see? You see the points on the QQ plot forming a perfectly straight diagonal line. The closer your little dots hug that line, the better the fit. But, real data is messy. So what happens when it's not a straight line? Well, any systematic deviation from that line tells a story. For instance, if your data is right-skewed, the points are going to form this very distinct curve, kind of like an inverted C-shape, pulling away from that perfect reference line. And if you see an S-shape, that's telling you something else entirely. It means that the tails of your distribution are different from a normal one. They might be heavier, meaning you have more outliers than expected, or lighter, with fewer. This all relates to a property called kurtosis, which is really just a fancy word for how pointy or flat your data's distribution is. Okay, so all of this leads to a really practical and sometimes heated debate among data people. When you're checking for normality, should you trust your eyes in these plots, or should you use a formal statistical test that spits out a p-value? Here's the paradox. Formal normality tests, like something called the Shapiro-Wilk test, have this really tricky relationship with your sample size. With a huge data set, they can scream significant over tiny, completely meaningless deviations from normal. But with a small data set, they often don't have enough power to detect important, meaningful deviations. They can be wrong in both directions. So you see the trade-off, right? A QQ plot is intuitive, but yeah, it's a little subjective. A formal test gives you an objective p-value, but like we just saw, that number can be really misleading. This is why so many statisticians argue that just looking at the plot is actually the superior approach. The real question isn't whether your data is statistically perfect, but whether it's practically normal enough for what you need to do. So with all that in mind, let's put these two incredibly powerful tools into your data analysis toolkit. Here's what you really need to remember. Grab a box plot for that 5-second summary. It is the fastest way to understand your data's basic shape, period. Then, pull out a QQ plot whenever you need to check that critical assumption of normality before you run other tests. And honestly, using them together is a 1-2 punch that's a powerful first step in exploring any data set. At the end of the day, these plots aren't just about checking some statistical box. They're about developing an intuition, a feel for your data. They turn those abstract numbers into actual shapes that have stories to tell. So the real question is, what stories are hiding in your data, just waiting for the right picture to bring them to light?
And subscribe now for more amazing videos just like that. Thanks for watching.